number of digits, number of digits, number of digits based problems, number of digits based problems, most important type, number of digits based problems. What will be the 10,000th digit? What will be the 10,000th digit? If I start writing all natural numbers, if I start writing all the natural numbers, if I start writing all the natural numbers from 1 sequentially, if I start writing all the natural numbers from 1 sequentially, what will be the 10,000th digit? What will be the 10,000th digit? This question I am taking because there is a question based on number of digits. Yesterday we solved. Yesterday I thought of taking this question based on a particular number of times. Question number 7 yesterday I solved. I got the answer 31. Same model question. Now I did not discuss this variety. This is a very important variety. A number of digit based problems. If I start writing all the natural numbers from 1 sequentially, what will be the 10,000th digit? Listen carefully. First I will start writing from 1. 1 to 9. These are all single digits. Single digits are total 9. From 10 to 99. Total there are 19 numbers. Each number is taking 2 digits. So 90 into 2, 180. 180 digits I used it. 100 to 999. Total 900 numbers are there. Every number I am using 3 digits. 900 into 3 is 2700. So 2700 plus 189. Total 2889 digits I used it already. I cannot take the remaining one because 1000 to 4 nines will become 9000 into 4, 36,000 it will become. Total 2889 digits are already written. I want 10,000th digit. Out of 10,000, 2889 digits are already written. Remaining I have to write 7111 digits. I need to write 7111 digits I need to write. Now see here. After 999, next number is 1000. Next number is 1001. Next it is 1002. That means every number I write is a group of 4 digits. Yes or no? Every number I write is a group of 4 digits. How many groups of 4 digits are there? Let us see. 4 17s are 68, 31. 4 7s are 28, 31. 4 7s are 28 plus C. 7111 is 4 into 1777 plus 3. What is these 4? A group of 4 digits. How many such groups I need to write? 1777 groups I need to write. And 3 more digits I need to write. So first group is 1000 plus 0. Second group is 1000 plus 1. Third group is 1000 plus 2. 1777 group will be 1000 plus 1776, which is 2776. Next number is 2777. From that number I want the third digit. First digit, second digit, third digit. Answer for this question is 7. 10,000th digit, if I start writing all the natural numbers starting from 1 will be 7. Again I am explaining step by step. First single digit 1 to 99. 2 digits 10 to 99, 90 into 2, 180. 100 to 999, 900 into 3, 2700. Total 2889 digits I wrote, but I want 10,000. Out of 10,000, 2889 remaining will be 7111 digits. 7111 digits needs to be written. After 999, every number is of the form 1000, 1001, 1002 and so on. Every number is a group of 4 digits. So 7111 is 4 into 1777 plus 3. 4 is the group contains 4 digits. 1777 is the group number. First group is 1000 plus 0. Second is 1000 plus 1. Third is 1000 plus 2. 1777th group will be 1000 plus 1776. 2776. After that 3 more digits need to be written. Next number is 2777. First digit, second digit, third digit. So answer for this question is 7. Answer for this question is 7. I hope it is clear. We will do one more question. 435th digit. 435th digit. So that after 2 problems it will be clear. 435th digit. 1 to 9 it is 9. 10 to 19 9. Total it is 90 into 2 180. Next number will result in 2600. Total 189 digits I already wrote. Out of 189 digits, 435, I want 189 digits to be written. Remaining is 6. 246 digits I need to write. 246. After 99, every group is of the form 100, 101, 102, 103. Every group of the form 3 digits. 346 is 3 into 82 plus no more digit. Last digit in the 82nd group is the answer. Now see here. First group is 100 plus 0. Second group is 100 plus 1. 82nd group is 100 plus 81. 181. No more digits needs to be written. Last digit is the answer. 435th digit is nothing but answer 1. Answer 1. I hope it is clear. Second one. 1 and 2 are one model. Third question. Third question. I hope the idea is clear. Third question. A book has 252 pages. A book has 252 pages. How many digits are used? How many digits are used to number these pages? To number these pages sequentially starting from 1. Number these pages sequentially starting from 1. How many digits are used to number the pages sequentially starting from 1? Answer. A book has 252 pages. 1 to 9, 9 digits I will use. 10 to 19, 9. Total 10 to 99 each. There are 90 numbers. Every number 2 digits are used. 180. 100 to 252. 100 to 252. Total 153 numbers are there. Every number 3 digits. So it is 459. 459 plus 189. Total 648 digits are used. Total 648 digits are used to number all the pages sequentially in a book of 252 pages. Question number 3, I hope it is clear. Question number 3, I hope it is clear. Question number 4. Question number 4. Question number 4. Please write down. Question number 4. Please write down. Ananya, I'll get back to your doubt in question number 7. Question number 7. Question number 7. Odd numbers. Question. A student comes and writes the first 100 even numbers on a blackboard, one beside the other. Number of times it is written. It is only even numbers, Ananya. So 2, 4, 6, 8 and so on. 100th even number is 200. These are total 100 even numbers. Numbers are not written sequentially starting from 1. These are all even numbers. Yesterday we discussed how many times the digit 2 is written. Units place 0, 12, 22, 32, 42, 52, 62. This question is slightly different from this question. 72, 82, 92. Total 10 numbers. Next one, 20, 21, 22 and so on up to 29, 10 numbers. In this number digit 2 is written twice, then 200, 200 it is 1, 10 plus 10 plus 1, 31. I hope you got it is clear, right? Now I think 1 minute, I think what she is telling in question numbers 1, odd numbers were taken and 102, 112, 102, 112, okay, I think 100 even numbers. Now 1 minute. Now 102, okay, here these are all 2-digit numbers. What she is telling seems to be right. These are all 2-digit numbers. If it is a 3-digit numbers, if it is a 3-digit number, now what we'll do is, if it is a 3-digit number, it is a 2, it is 0, so this will become 102. This is one case. If this is there, 112, okay. So next case is, if it is a 2, this is 12 and so on up to 192. Yes, she is right. These are all the cases. These were not taken yesterday in the question. So I think only 2-digit numbers we have taken. 3-digit number 102 needs to be counted. 112 needs to be counted. Still we will get more numbers. I hope the idea is clear, right? She is right. We have missed out taking out a 3-digit number. Next one. Ananya, you are right. I hope the logic is clear. Any calculation mistake is there, please take care of it. I think this is clear, right? Next one. Now I think this method is clear. Now we will see any other digit based problems are there. Digit based problems are there. Digit based. If I miss out any particular case, kindly consider that case also. It is number of zeros, the successive division, the Chinese remainder, these divisibility rule, these, let me see if any digit based questions are there. Right. How many 3-digit numbers exist which has at least one of the digit? At least, morning we discussed, at least once. At least once is nothing but total minus none. Total minus none. Total, listen carefully, at least total minus none. Total, this I can keep any digit from 0 to 9, because if I keep a 0, I will get a 2-digit number. How many 3-digit number? How many? Okay, first we will do total numbers. Total numbers less than, first I will do the question, less than or equivalent to 1000. Then I will discuss this. Right? So first I am doing this example, total numbers I will do because I wanted to convey a point. How many total numbers less than or equivalent to 1000 has at least one of the digit as 5? This is not question answer for this question, sir. I am doing total because I wanted to explain a point. Leftmost can take 0. If I take leftmost 0, I will get all the possible 2-digit numbers. Leftmost I can take 0, I will get all single digit numbers. Leftmost I can take all 0 to 9, right? If you observe closely, if I keep 0 here, I got 2-digit numbers. If I keep 2 zeros here, I got single digit numbers. My question is, how many total numbers less than or equivalent to 1000 as at least one of the digit? How many total numbers less than or equivalent? So total numbers from 1 to 1000 is 10 cube. 0 should not be counted. 10 cube minus 1. So this is very simple. 1 to 999 is nothing but 10 cube minus 1. Minus. Here it is 0 to 9. None. 5 should not be there. 0 to 9. 5 should not be there. 0 to 9. 5 should not be there. Minus of 9 cube minus 1. 1000 minus 729 is 271. This is for the question total numbers. Total numbers less than or equivalent to 1000. Total numbers less than or equivalent to 1000. Total numbers. I hope it is clear, right? total numbers less than or equivalent to 1000. This is the question for how many total numbers less than or equivalent to 1000. Now we will solve question number 30. I hope why this 00 is clear to you, right? If you keep 0 in the tens hundreds place, I will get 2-digit numbers. If I keep 0 in tens place and hundreds place, I will get a single digit numbers. Why this 1 is subtracted? Why? Because all the values, if it is taking 0, that becomes a value 0. How many natural numbers? How many natural numbers? I hope it is clear. Now question number 30. This is one way of solving this question. Question number 30. These only how many 3-digit numbers? So method 1. Method 1. When I say it is at least once is nothing but only once plus only twice plus only thrice. This is another way to solve. Only once, only twice and only thrice. Only thrice 555, there is one number. Only twice, units place and tens place 5. This can be any value from 1 to 9 but not 5. Because why 0 cannot be taken? Because it's a 3-digit number. 5 cannot be taken because it should be 5 only should be written twice. So it is 5 and 5. So this will be 1 and 9. 5 cannot be taken. This will be 5 and 5. This will be 1 and 9. 5 cannot be taken. So 1 and 9. 1 to 9 total 9 numbers. 5 should not be taken. 8, 8, 8. So 24 I got. 24 I got. Only once. Only once means here 5, here 5 and here 5. Only 3-digit number. That means 1 to 9. 5 cannot come here because only once it should be there. Here 0 to 9. 5 cannot come here. 5 cannot come here. 1 minute. I think here it can be 0 to 9. Here also it can be 0 to 9. Leftmost cannot be 0. So it will be 10. How many cases? 1 to 9. 9 cases. 9. 1 to 9, 9. So it is 8. Next it is 0 to 9 is 10. 5 cannot come. 5 cannot come. Here I will get 8 cases. 1 to 9 is 9. 5 cannot come. 0 to 9, 10 cases. 9 numbers. Here also 9 numbers. Here it is 1 to 9. 5 cannot come. 0 to 9, 5 cannot come. I hope you are all there with me. 0 to 9, 5 cannot come. 0 to 9, 5 cannot come. So 0 to 9 is 10, 5 cannot come. 5 cannot come is 9. 0 to 9 is 10, 5 cannot come. 9 9s are 81. These 81. Next case is 1 to 9. 1 to 9 is 9 cases. 8 cannot come. 8 into 9. 72. Here also 1 to 9. 9 cases. 9 cases. 8. 8 into 10. 9. 72. Add all this, you will get the answer. I hope it is clear. So answer is 1 plus 8 plus 9 plus 9 plus 72 plus 72 plus 81. Again I am repeating. At least once is nothing but only once, only twice and only thrice. Only thrice 555 I will get a 5 possibility. Only twice means there are 3 cases that will come. It could be units place and tens place. It could be units place and tens place. It could be units place and hundreds place. And it could be hundreds place and tens place. If it is in units place and tens place, hundreds place cannot be 0. Because if it is 0, I need to get a 3-digit number. So it will be from 1 to 9. 5 is written only twice. So 5 should not come. In between 0 to 9 is 10, 5 cannot come. 0 to 9 is 10, 5 cannot come. So 9, 8 cases. I hope it is clear, right? What are that 8 cases? In case if you want 155, 255, 355, 455, 555 cannot be taken because it is already written. 655 to 7. Only thing, little bit of counting is there. Again, there is one more method number 2, which I'll come back after I discuss a particular concept. Method 1. This is the method 1. But at least once is nothing but total minus none. Method 2, I think in case if you want to just do it, method 2. Method 2 is nothing but at least once is nothing but total minus none. So total 3-digit numbers are 900 minus none. 5 should not come. At least one of that means here it can be 1 to 9, 5 cannot come. Here it is 0 to 9, 5 cannot come. Here it is 0 to 9, 5 cannot come. Are you all with me? Idea clear, right? So, clear, right? 900 minus 1 to 9, it is 9 cases, 8 into 9 into 9. 8 9s are 9 9s are 81, 81 8s are 648. 81 minus 648, which is nothing but 252. 252 is the answer. I hope the idea is clear. There is one more method 2. That also I will explain. At least once is total minus none. Write method 3. Please write down method 3. 2 for 52. Method 3. Method 1, don't use it in your exam. Method 3. This method 3, those who attended my session number 1, I wrote a point. Any single non-zero digit is written 20 times, but in 19 numbers in a set of 100 consecutive numbers, consecutive natural numbers, in a set of 100 consecutive natural numbers, 1 to 100, 101 to 200, and so on. Proof. Those who attended yesterday, they might have understood it. Write this statement. Any single non-zero digit is written 20 times but in 19 numbers. Suppose if I take 2, 0 to 12, 22, 32, 42, 52, 62, 72, 82, 92. 20, 21, 22 is duplicated. Right? 23, 24, 25, 26, 27, 28, 29. How many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19 numbers it is present, but there is a number where the digit 2 is present twice. That number is 22. That is the reason please read the statement. Every single non-zero digit is written 20 times but in 19 numbers. There is a number where it is written twice. So it is written 20 times but in 19 numbers in a set of 100 consecutive natural numbers. How this method can be used to solve this? Now, how many 3-digit numbers? Total 3-digit numbers are 900. At least one means there is 500, 501, 502, and so on up to 599. 100 numbers definitely 5 will be there. 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 Out of 900, 100 numbers, definitely 5 will be there. Remaining 800 numbers. In a set of 100 numbers, every single digit is written. Every single digit is written in 19 numbers but 20 times. Just now we discussed. Out of 900, 100 numbers, definitely 5 will be there. So 100 will come. Remaining 800, every set of 100 numbers, every number, every single digit is written. At least means it is written at least in 90 numbers, one number twice. 800 means in every set of 100, I will get 19 numbers. 800 means 8 into 19 plus 100, which is 152 plus 100, which is 252. I hope method 3 is also clear. Method 1, avoid it. Why? Because only once, only twice, only thrice, like that 3 steps you have to do it. Method 2 is a negation method. What is a negation method? At least 1 is nothing but total minus none. At least 1 is nothing but total minus none. Method 3 is the concept which uses in a set of 100 consecutive natural numbers, every single digit, every single non-zero digit is written in 19 numbers, but there is a number where it is written 20 times. Question is asking for how many 3-digit numbers, so not the digits, so these should not be taken. 19 out of 900, 100 numbers it is present. In remaining 800, set of 100, 19 times, 800 8 times, 8 into 19, 152. 152 plus 100 is 252. I hope this logic is clear. Next one, how many 3-digit numbers exists which has exactly one of the digit as a 5? So exactly, I think exactly one digit should be 5. Exactly one digit should be 5. Exactly one digit should be 5 means 3 cases. Case 1, 5 is in units place. Case 2, 5 is in tens place. Case 3, 5 is in hundreds place. Here it cannot be 0, so it can take from 1 to 9. Only once exactly one digit, so 5 cannot come. Here it is 0 to 9. 5 cannot come. In between 0 can be present. Here it is 1 to 9, 5 cannot come. Here it is 0 to 9, 5 cannot come. Here it is 0 to 9, 5 cannot come. 0 cannot come in the leftmost place. 0 can come to the rightmost place. 0 to 9, 5 cannot come. 0 to 9 is 10, 5 cannot come. 9. 0 to 9 is 10, 5 cannot come. 9. 9 9s are 81. 1 to 9 is 9 cases, 5 cannot come. 8. 0 to 9 is 10, 5 cannot come. 9. 8 9s are 72. 1 to 9, it is 9 cases, 5 cannot come. 0 to 9 is 10, 1 case. So 72 plus 72 plus 81, 72 plus 72, 144 plus 81, 220. Answer is none of these. None of these. Please analyze all the questions based on the digits. How many times the digit 3 is written? If a book has how many pages? How many times the digit 3 is written at least once? How many times the digit 3 is written exactly once? All these varieties, very good in it. I think leftmost 0, why it cannot come? Because it is only a 3-digit number. Why 5 cannot come? Because I want exactly one of the digit as 5. Next one. What is the minimum number of identical cubes which one can construct a solid cube? A solid cube. In this cuboid there is a size. Like that, how many cubes can be constructed? Okay. So length is 20. Breadth is 16, height is 12. Cube means all sides are equal. So 20, 16 and 12. What is the value that makes it equal? Which is HCF of 20, 60 and 12, which is nothing but 4. So actual number of area of the cuboid is 20 into 60 into 12. Cube area is, volume is A cube. Volume of the cuboid is LBH. Volume cube all sides are equal means 4 into 4 into 4. This is LBH volume. This is A cube volume. 4 5s are, 4 4s are, 4 3s are, 23s are 60. Right? So total volume of the cuboid is LBH. I want how many cubes that can be formed out of that cuboid. Cube means all the sides are equal. 20, 60, 12, the value that will be equal is 4. Next one. Very, very good question. If all the factors of 72 are written in increasing order, the factor which occupies the 26th position. Concept. Suppose if I take 12, the factors of 12, if it is written in increasing order or ascending order, 1 is a factor of 12, 2 is a factor of 12, 3 is a factor of 12, 4 is a factor of 12, 6 is a factor of 12, 12 is a factor of 12. Now see, suppose the factor which is second from the right, can I say it is nothing but number divided by second from left? Can I make this point? So this is nothing but 12 by 2. Factor which is third from the right, which is nothing but number divided by factor from third from right, that means nth place from the left, nth place from the right is nothing but number divided by nth place from the left. Please make a note. Very, very important concept. Nth place from the right is nothing but number divided by nth place from the left if the factors are written in ascending order. If the factors are written in ascending or always as descending order. If the factors are written in ascending order or descending order, number divided by nth place from left will give you nth place from right. You don't need to find out these values. If these are enough, automatically the resultant multiples will come. Nth place from right is nothing but number divided by nth place from left. This is the concept I am going to use. Factors of 720 are, 720 is nothing but 360 into 2. 360 is nothing but 8 into 9 into 5 into 2. 8 is nothing but 2 cube. 9 is 3 square. 5 power 1 into 2 power 1, which is 2 power 4 into 3 square into 5 power 1. 2 power 4 into 3 square into 5 power 1 means 2 power 0 to 2 power 4, 3 power 0 to 3 power 2, 5 power 0 to 5 power 1, 5 into 3 into 2. Total 30 factors are there. Total 30 factors are there for this number. If all the factors are written in the increasing order, factor which occupies 26th position, 26th position from the 26th position, factor for 72 is 1, 2, 3, 4, 5, 6 and so on. This 30th position, this 29th position, 28th position, 27th position, 26th position. That means it is nothing but first from right, second from right, third from right, fourth from right, fifth from right, fifth from right. Fifth from right is nothing but number by fifth from left. Fifth from left. Number is 720. Fifth from left is 1, 2, 3, 4, 5. 720 by 5. Answer is 144. Answer is 144. Very simple question. He is just tweaking the question to confuse you. There is nothing in this question. Nth factor from the right is nothing but number divided by nth factor from left. 26th position. Total 30 factors are there. 30, 29, 28, 27, 26. Fifth factor from right is nothing but number by fifth factor from left. number by fifth factor from left. Fifth from right is nothing but number divided by fifth from left. 720 by 5, 144. I hope this idea is clear. Question number 38. How many prime numbers P such that exist such that means numbers are after 1999 factorial plus 1 it is plus 2. It is 1999 factorial plus 3, 1999 factorial plus 4 and so on up to this will become 1999 factorial plus 1998. Can I say this is an even number? Because 1999 factorial is nothing but 1999 into 1998 and so on up to 3 into 2 into 1. Even number plus even number, even number. Is there any even number other than 2 which is a prime number? No. 1999 factorial, it contains 3 and so on. That means this is divisible by 3. Divisible by 3. 3 is also divisible by 3. Is there any number other than 3 which is divisible by 3 but a prime number? No. This is an even number, this is an even number. Answer is an even number. This is an even number, this is an even number. Answer is an even number. Answer is 0. No prime numbers exist. No prime numbers exist between these values. Right? It's a very simple question. Seems to be very, very difficult. Those of you who are preparing for CAT, this is an original CAT question. This is an original CAT question. This is how the questions are tested in your competitive examination. They will not ask you a straightforward question. They will ask you the definition of a prime number using a problem. 1999 factorial plus 2. This is an even number, even number. Divisible by 3, divisible by 3. Even number, even number. Even number, even number. I hope it is clear. Next, which all questions are pending? Find the smallest number. Find the smallest number which when divided by, okay? Question is, find the smallest which when divided. This is called as a dividend. The number which is getting divided. This is nothing but divisor. This is nothing but quotient. And whatever remaining that is left, that is called as a remainder. That is called as a remainder. Dividend equivalent to divisor into quotient. Divisor into quotient plus a remainder. This is the concept. Remember this. Now find the smallest number by which 3750 should be divided. Options are there. Smallest it is given. If I divide 3750 by 2, this is nothing but 1825 3750. 1825, is it a perfect square? Right? Perfect square, just check it out. 35 whole square, 1 plus 8, 9, 11, 6. Now one important point. Every perfect square has a digital sum 1, 4, 7 or 9. Every perfect square has a digital sum 1, 4, 7 or 9. Remember this. Every perfect square has a digital sum 1, 4, 9. If a number is a perfect square, it should have digital sum 1, 4, 7 or 9. 5 plus 2, 7, 15, 16. 7, 15, 16. 16 is 7. So 1825. 1825 means 35 square is 1225. 40 square is 1600. 45 square is 2025. So remember the good example we have taken. If a number is a perfect square, it will have digital sum 1, 4, 7 or 9. If a number has got digital sum 1, 4, 7 or 9, it may or may not be perfect squares. Reverse may or may not be true, which I said it in my old videos also. So it is not value. If it is 3, this concept is used in the second problem. 3, if I divide it, 3, 1, 2, 5, 0, 3750. 1250 digital sum is 8. It is not possible. 5 if I take 5 sevens are 5, 750. 3750. 750 digital sum is 3. 3 cannot be a perfect square. 6. If I take 6, let us check with 6. 3750 divided by 6. 6 6 are 625. 3750. 625 is a perfect square. 625 is a perfect square. 1 cannot be the answer because 1 goes 3750 times. 3750 digital sum is 3 plus 7 10, 10 plus 5 15. 15 digital sum is 6. Option E is eliminated because of digital sum concept. Option C is eliminated. Option B is eliminated. Option A, even though the digital sum is 7, it is not a perfect square. Why? Because 45 square is 2025. 35 square is 1225. 1825 is not coming into our picture. Now, next one. The smallest natural number such that n factorial is divisible by 1000. 1000 is nothing but 5 cube into 2 cube. 5 cube into 2 cube. Right? Now see, power of 5 should be 3. Power of 5 minimum it should be 3. Suppose if I take 10 factorial. 10 factorial means only 2 powers will become. 10 power factorial is 5 power 2 into k. If I take 15, 5 ones are 5 threes are. So minimum power of minimum factorial will give our for 5 as a 3 is 15. Let us check. Let us check whether 15 is giving you power of, right, 1000, 15 factorial if I take. 15 factorial is nothing but, if I take 2 sevens are, 2 threes are, 2 ones are. So 2 power 11 into 5 power 3. 5 power 3 into k. This is nothing but 2 cube into 5 cube into 2 power 8 into k. 125 into 8 is nothing but 1000. So answer for this question is 15. Answer for this question is 15. Answer for this question is 15. Right? I hope it is clear. I hope it is clear. So there is another important note here. We will do it. Right? These not important. These everybody can solve it. But one important conclusion which I wanted to say. Please write down. N factorial ends with x zeros. N factorial ends with x zeros. Then n is always greater than 4x. N factorial ends with x zeros. Then n is always greater than 4x. Right? The proof in this one, it is already discussed in my highest powers class. N is greater than 4x. So 1000 is 5 cube into 2 cube. So power of 5 and 2. That means it will have 3 zeros at the end. Yes or no? It will have 3 zeros at the end. So n factorial is ending with 3 zeros. 3 zeros. That means n should be how much? N should be greater than 4x. N should be greater than 12. 10 is out, 12 is out. 15, 20, 25. Smallest natural number. 15 is the answer. You don't need to compute it like this. N factorial ends with x zeros. That means n should be greater than 4x. N should be greater than 4x. I hope the idea is clear. Next one. All the natural numbers from 101 to 200 are multiplied together. So 101, 102, 103 and so on up to 200 are multiplied together. Find the number of zeros at the end of this product. So what we will do is, we will multiply and divide by 100. 1 into 2 till 100 into 101 and so on up to 200 divided by 1 into 2 into 3 till 100. So this is nothing but 200 factorial divided by 100 factorial. 200 factorial divided by 100 factorial. Number of zeros at the end is nothing but 10 power k. So for 200 For 200, 200s are, 225, 50s are, 225s are, 212s are, 26s are, 23s are, 1s are. So 2 power 197 I will get. Here it is, from here to here it is 97. So 5 I will get. 5 40s are, 5 8s are, 5 1s are. So it is nothing but 49. Here it is nothing but 24 into remaining prime bases K1 and K2, which we don't require. So these are nothing but 197 minus 100 is 2 power 100 into 5 power 25 into K3. This can be written as 2 square into 5, 10 we require, right? 2 into 5 power 25 into 2 power 75 into K. 10 power 25. Answer for this question is 25. Multiply and divide to get a factorial format. Then you can easily apply power of 2, power of 5 and you can do it. Even you can condense here also. You don't need to do all this. Just look at the power of 5, because if the number is a factorial, number of zeros at the end is always highest power of 5. So 44th I did it, 42nd over, 41st over, 40 over, 39 over, 38, 37, 36, 35, 34. Now, the number when divided successively by 7, 5 and 3, successively. Suppose, what is a successive division? First traditional method, then optimal method. What is a successive division? This I call it as a dividend. These I call it as a divisor. These I call it as a quotient. These I call it as a remainder. This is the generic form of division. Dividend, divisor, quotient, remainder. If the quotient becomes the dividend in the next division, if the quotient becomes the dividend in the next division, this is called successive division. Successive division. Please write that important point. If the quotient in the first division, if the quotient in the first division becomes the dividend in the next division, then that is called successive division. If the quotient in the first division, becomes the dividend in the next division, then it is called successive division. Traditional method I will discuss, then I will discuss a single step solution, how you should get the solution. It's very, very important for you to know the definition of successive division. Quotient becomes the dividend in the next division. Quotient becomes the dividend in the next division. Now see here. Method 1. A number is there. It is first divided by 7. It leaves a remainder 5. So n is nothing but 7a plus 5. Dividend, quotient becomes the dividend. Then a is there. A is divided next by 5. We do not know the quotient, but we know that remainder is 3. A is nothing but 5b plus 3. Dividend equivalent to divisor into quotient plus remainder. B is there. B becomes the dividend. It is divided by 3. We do not know the quotient, C, but we know the remainder as 1. So B is nothing but divisor into quotient plus remainder. So if I substitute here, A is nothing but 5 into 3C plus 1 plus 3, 15C plus 8. 15C plus 8. If I substitute here, n equivalent to 7 into 15C plus 8 plus 5. 7 into 15 is 105. It is divided. 7 8s are 56 plus 56 plus 5. 61. 61 divided by 105. Answer is 61. 61 divided by 105. Answer is 61. This is the generic method. In the exam, kindly do not solve this method, which is a time consuming method. It takes a little time. Time consuming approach. By definition, we have solved it. By definition, dividend equivalent to divisor into quotient plus remainder. I applied this and I got the answer. I applied this and I got the answer. Question number 33. Method 2. Method through. Answer is 61. Number is divided by 7 remainder 5. 5 remainder 3. 3 remainder 1. Is it clear? Number when divided by, when divided successively by, when divided 7 it is 5. 5 it is 3. 3 plus 1. Now let me tell you this method. Add this both. 3 plus 1 4. Multiply this one. 4 5s are 20. Again add this one. 20 plus 3 23. 23 into 7 161 plus 5. That means add this and multiply. Add this and multiply. Add this and multiply. I will tell you why am I doing this. What is this addition that is coming? The last number which we got is 3b plus 1, right? And to that one only I multiplied by 5 into 3b plus 1 plus 3, right? Just see the method number 1. That means horizontally add it. Horizontally add it. Diagonally multiply it. Diagonally multiply it. Diagonally multiply it. Very simple, you will get it. 3 plus 1 4. 4 5s are 20. 20 plus 3 23. 23 3s are 161. Plus 5 166. 166 divided by 105. Answer is 61. Idea clear? We will do few more questions. Few more questions. It is simple because of equations only. Method 1, if you understand, if you see it, you will understand it. 6 8 5 2 3 1. What is the form of the number? What is the form of the number? 5 plus 1 6. 6 8s are 48. Plus 3 51. 51 6 are 306. Plus 2 308. Form of the number is 308 into k. Right? Why it is 5 plus 1 I am doing it? Any number when divided by 5, remainder 1 is nothing but divisor into quotient plus remainder. Yes or no? 5 into something plus 1. Right? Again that number is multiplied. Are you all with me? Question number, method 1, if you understand it, it's very clear. Successive approach. 32 we solved it. In how many ways? 1 billion. Billion means 3 6 9. 10 power 9. Which is nothing but 2 power 9 into 5 power 9. Can be written as product of two numbers such that neither of the numbers is a multiple of 2. No variables are there. So it is an unordered pair. Unordered pair, reverse is not allowed. Already we discussed. Unordered pair, reverse is not allowed. You cannot take reverse. Reverse is not allowed. So you cannot take it as 1 into 10 power 9. One of them is a multiple of 10. 10 into 10 power 8. One of them is a multiple. Only one case is there. 2 power 9 into 5 power 9. This case we cannot take. Why? Because it's an unordered pair. In unordered pair, reverse cannot be possible. Reverse cannot be possible. To all enrolled students, once you get this video of close to 44 problems, hopefully by tomorrow night, including our yesterday's class, please complete it in the next 2 days, because otherwise it will get piled up. I have very high hopes on all the enrolled students. 29. Next one. Find the largest power of 10 factorial that will divide 100 factorial. 100 factorial divided by 10 factorial power k. Remainder should be 0. Find the k value. This is the question in a mathematical expression. Find the question. Write 10 factorial power k. 100 factorial is nothing but 2 power 97 into 3 power 48. 97 is 2 50s are, 2 25s are, 2 12s are, and so on. 48 is 3 33s are, 3 11s are, 3 3s are, 3 1s are. into 5 power 24 and so on I will get. Till 10 factorial, which are all the prime numbers? 2, 3, 5, 7. So write down till 3. 100 I will get 7 14s are 7 2s are 7 power 16 into k. 10 factorial is nothing but 2 power 2 5s are 2 2s are 2 1s are 2 power 8 into 3 power 4 into 5 power 2 into k2. Now see here. Now which number what is the largest power of 10 factorial? This is nothing. 7 also we should take. 7 power 1. What is the largest power of 10 factorial that will divide? 7 power 1. If I take 16, 16, everything should be divided. 7, 1, 16, 16 I will get. 2 16s are 32. 5 power 24 is not divisible by 5 power 32. If I take 10, 2 power 8 into 3 power 4 into 5 square into 7 power 10. 8 10s are 80. 97 will divide 80. 48 will divide 40. 40 will divide 48. 24 gets divided by 20. 16 gets divided by 10. So answer is 10. In fact 11, is it possible? 11 it is possible. 11, 10 also is possible. Question is largest, right? 11. 8 11s are 88. 97 will divide 88. 48 will divide 44. 24 will divide 22. 11. These also dividing. Highest power we require. So check for 12. 12 8s are 96. Okay. 12 4s are 48. 24. So all these are dividing. Highest is nothing but 12. So answer for this question is 12. You don't need to do all this. Just check it out. What is the highest among these? Anyway 16 is eliminated. 10 11 12 20. Check it out. If 12 is satisfying, 10 and 11 will not satisfy, because among 10 11 12 the highest is 12. If 20 is satisfying, 10 11 12 is by default eliminated. I hope the idea, I came from the lowest. You should have ideally come from the highest. 30 over, 31 over, 32 over, 33 over, 30 over, 29 over, 28 over. Next one, 5 power. Find the remainder. We missed this remainder question. 5 power 25 power 125 divided by 11. According to Fermat's theorem, a power p minus 1 when divided by p is 1. So these 5 power 10 divided by 11 is 1. So remainder 25 power 125 when divided by 10. 10 is 2 into 5. 25 divided by 2, remainder 1. 2a plus 1. 25 is perfectly divisible by 5. So it is 5b. 2a is nothing but 5b minus 1. 2a is nothing but 4b plus b minus 1. Even number. b minus 1 should be 0. So b equivalent to 1. B equivalent to 1. So we got the answer as 5. That means 25 power 125 when divided by 10. When divided by 10, answer is 5. 10a plus 5. 10k plus 5 we will see. I hope till now it is clear, right? This is the question. This is the first step. 5 power 10 by 11. This is the second step. 25 divided by 2, remainder 1. 25 divided by 5, remainder 0. This is the third step. I got 5. This is the fourth step. Finally we got 25 power 125 as 10k plus 5. 25 power 125 as 10k plus 5. So this is nothing but a remainder of 5 power 10k plus 5 divided by 11. So this is nothing but 5 power 10k into 5 power 5 divided by 11. This is 1. 5 power 5. 5 square whole square into 5 power 1 divided by 11. 5 square is 25. 11 twos are 22. 3 square is 9. 9 fives are 45 divided by 11. 11 fours are 44. Positive remainder is 1. Positive remainder is 1. I hope the idea is clear. Denominator 11 means wherever the denominator is a composite number, whenever the denominator is a composite number, prime number in this context, use Fermat's theorem. Use Fermat's theorem. Use Fermat's theorem. 27 is an easy question. 28. Point AB, AB, AB. AB, AB, AB means it's a recurring decimal. It's a recurring decimal. Okay. AB, AB is getting repeated. Point AB bar. So this is nothing but AB by 99. Where C and D are single digits relatively, if A and B are also single digits, not necessarily distinct. Okay, they can be same also. Okay. How many values can the number assume? Equivalent to dash by D. D is a single digit number. D is a single digit number. How many values AB can take such that AB by 99 will result in D? AB by 99 will result in D. That means AB, can I take, what are the factors? AB, what are the, can I take 11? 11 by 99 is 1 by 9. There is a possibility. Can I take 22? Why am I taking 11 by 22? AB by 9 into 11. That means AB should be a multiple of 11. AB should be a multiple of 11. 11, 22, 33. 11 by 99 is 1 by 9. 22 by 99 is 2 by 9. 33 by 99 is 1 by 3. 44, 55, 66, 77, 88. 99 cannot be taken because 99 by 99 is 1, which will become a terminating decimal, but the question is a recurring decimal. Question is a recurring decimal. Are you all with me? Right? Suppose you might ask me, sir, here AB can also be a multiple of 9. If AB is 18, 18 by 99, 9 twos are 9, 11s are 2 by 11. I will get a 2-digit number, but it is saying that D is a single digit number. AB can be a multiple of 9, AB can be a multiple of 11. AB cannot be a multiple of 9, so AB has to be a multiple of 11. 26th clear. Next one, how many natural numbers less than 100? Number should be less than 100. A number is there. It is divided by 7, it is divided by 8, it is divided by 9. Positive reminders are first case 5, second case 4 and third case 2. Third case 2. Are you all with me? Very, very interesting case it is. Right? Positive reminders are not same. 5, 4, 3. Negative reminders are not same. There is no correlation. So we'll go by the equations method. A number when divided by 7 gives a remainder 5. 7a plus 5. A number when divided by 8 gives a remainder 4. A number when divided by 9 it gives a remainder 3. Let me take this combo. 7a plus 5 equivalent to 8b plus 4. 7a equivalent to 8b minus 1. 7a equivalent to 7b plus b minus 1. These are divisible by 7. These are divisible by 7. B minus 1 should be divisible. So b value is 1. If b value is 1, 8 plus 4 is 12. Lowest remainder is 12. The number is perfectly divisible by 7 and 8. So the form of the first two numbers is 56k plus 12. 56k plus 12. This combine with the third value. If I combine 56k plus 12 equivalent to 9c plus 3. 9c equivalent to 56k plus 9 divisible by 9 divisible by 9. K value is 0. If K is 0, this will be 12. The lowest number which when divided by 789 gives a remainder 543 is 12. 12 when divided by 7, remainder 5. 12 when divided by 8, remainder 4. 12 by divided by 9, remainder 3. So the form of the number is lowest is 12 and it is divisible by LCM of 789 into K. 789 are the co-prime numbers. Co-prime LCM is their product. 9 8s are 72, 72 7s are 504. It is exceeding 100. Answer is no value. Answer is no value. This question wantedly I kept it in the PPT. Why? Because generally in your books positive reminders will be same, negative reminders will be same. In some steps negative reminder will be same. That also I will take it as an example right now. Here the positive reminders are not same, negative reminders are not same. A number when divided by 7, remainder 5. A number when divided by 8, remainder 4. 7a plus 5 equivalent to 8b plus 4. 7a is 8b minus 1. 7b plus b minus 1. Divisible by 7, divisible by 7. B minus 1 should be 0. B will be 1. If I substitute 1, 8 plus 4 is 12. So 12 plus LCM of 7 and 8K. 56K plus 12. Equate with the third one. Equate with the third one. I hope it is clear. Now one important shortcut in this model. Important key point. Important key point. Suppose a number is there. I thought initially that this problem is of this model. 789. Positive reminders will be 246. 246. 789 and the positive reminder is 246. Listen carefully. Difference between the positive reminders is 2. Difference between the divisors is 1. If the difference between the positive reminders, if the difference between positive reminders is K times the difference between the divisors, K times the difference between divisors, in kth step, negative remainder will be same. In kth step, negative remainder will be same. In kth step, negative remainder will be same. Extremely important point. A number when divided by 789 gives a positive remainder 246. 246 positive remainder needs not same. First step, 2 minus 7 is minus 5, minus 4, minus 3. First step negative remainder is not same. Next step it will be 2 minus 7 is minus 5, minus 5, minus 7, minus 4, minus 8, minus 3, minus 9. So answer is nothing but LCM of 7789K minus 12. I hope the idea is clear. LCM of 789 into K minus 12. Beautiful case where the positive reminders are not same and the negative reminders are also not same. But if the difference between the positive reminders is K times the difference between the divisors, in the kth step negative remainder will be same. First step it is minus 5, minus 4, minus 3. Second step it will be minus 5, minus 7, minus 4, minus 8, minus 3, minus 9, minus 12 you got. Answer is LCM of 7, 8, 9 into K minus 12. Very, very important point. I will do one more question based upon this model. Second model. Please write down. First model I hope it is clear. Second one. A number when divided by 10, 11 and 12. Positive reminders are 1, 4 and 7. 1, 4, 7. What is the gap? 3. 10, 11, 12. What is the gap? 1. In the third step, I will get the same negative remainder. 1 minus 10 minus 9. These minus 7. These minus 5. Second step, minus 19, minus 18, minus 17. Third step, minus 19, minus 10, minus 29, minus 29, minus 29. If you observe, in the third step negative remainder will be the same. In the third step negative remainder will be the same. In the third step negative remainder will be the same because this and this relationship is 3x times the difference. 3x times the difference. Don't think that this question is a difficult question. If you know this shortcut, if you know this concept, you can crack this question very, very easily. Next one, this is a set theory based question. Let us first attack all the easy questions. A number when successively divided by 8 and 9 gives remainders 5 and 4. I told you, horizontally it is addition, vertically it is multiplication. 9 plus 4, 13. 13 8s are 104. 104 plus 5, 109. Number is 109. Number is 109. What will be the remainders if the order of division is reversed? That means first 109 is divided by 9. 9 12s are 108. Remainder is 1. 12, we already discussed, quotient becomes the dividend in the next one, 8. 8 1s are 8. Remainder is 4. So answer is 1 and 4. Answer is 1 and 4. I hope the idea is clear. A simple concept based on successive division. 21st question. How many factors for this will have exactly 1 0 at the end? So this is nothing but 2 power 4 into 3 power 7 into 5 square. Exactly 1 0 at the end is 10k. And k is not any multiple of 10, it should not take. 10k means 2 into 5 is taken out. Remaining is 2 cube. Remaining is 3 power 7. Remaining is 5 power 7. Any number multiplied by 10, it becomes, right, a multiple of 10, exactly 1 0. How many it will be? 4 into 8 into 2. 4 into 8 into 2. Answer is nothing but 64. 4 into 8 into 2. Answer is nothing but 64. I hope the idea is clear. Any number to have an exactly 1 0 at the end, it will have 10k. This is also advanced level. This will go to session number 4. This also, one more factors question is there. This also we solved. I think question number, a natural number n is such that it has x factors. I think this will take about 5 minutes to solve. Now 1 is there. I think I will add few more questions.
You can learn any subject, anywhere, any place, and on the go. Come, let us go the other way learning. Download our revolutionary app for free, ANC.